Hello and welcome to the first video of the first section, DevOps and DevOps tools. In this first lesson, we are going to learn what exactly is DevOps and what are the building blocks and things like that. So let's get started. So what is DevOps? Is it a concept? Is it a practice? Is it a process? Is it a technology? Or is it the combination of all of the above? That is what we are trying to understand, because we have a lot of gray areas before somebody starts learning DevOps. You have different definitions on the web. You have different people have different perspectives. So the first thing or the first task is to eliminate this confusion. So the first definition which I've taken is from Wikipedia, which says that it's a software development method that stresses communication, collaboration, and integration between software developers and information technology operations professionals, as we call them. Another definition I have taken is from Rackspace, which needs no introduction. As per Rackspace, it's not exactly a tool or a product. It's more like an approach to operations by uniting development and operations teams to automate and standardize processes for infrastructure deployment. You get faster innovation, accelerated time to market, improved deployment quality, better operational efficiency, and more time to focus on your core business goals. This is a little bit lengthier, but I would say this is one of the most accurate definitions of DevOps out there in the market. Let's go through a couple of more definitions. Patrick Debois is one of the chief DevOps proponents. He is one of the early adopters of DevOps and evangelists who has traveled around the world and speaking about DevOps globally. He says DevOps is a combination of software development and operations, and as its name suggests, it's a melding of these two disciplines in order to emphasize communication, collaboration, and cohesion between the traditionally separate developer and IT operation teams. Right? And finally, we will discuss the definition given by Amazon. Companies like Amazon, Google, Rackspace, these are the companies who have been practicing DevOps in their companies, in their software delivery for the past 10, 15 years or more. It's just that they did not have a definition for it, but they were practicing all these processes which we know them today as DevOps ecosystem. So as per Amazon, DevOps is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. Now, high velocity is the keyword here, because this is the major difference between a company who is practicing DevOps and a company who is not practicing DevOps. So one of the common questions we get from the people who are starting their DevOps journey is, where exactly DevOps lies, right? Is it a development practice? Is it a operations practice, or do we have QA fit in the ecosystem or not? So I think this is one of the very good diagrams which will clear all your doubts. And as you can see here, it's an amalgamation of all the three major technological fields, because if you speak about IT industry, anybody can be fit into one of these three major roles. People will typically come from the development background, or the operations background, or the quality assurance or testing background. Now, when we say operations, technology operations, we are talking about people who are server admins like Windows or Unix or Linux, VMware, or they can be networking professionals. They can be storage professionals working on SAN technologies. It's primarily, if you talk about overall umbrella of technology operations, this will be anybody who is helping maintain the data center operations. That's what we are talking about, the technology operations. So pretty much anyone who is somewhere falls into the ecosystem will be part of the technology operations. So these are the three major fields which have in which we can divide the IT professionals. And as you can see, we have DevOps professionals coming in from all the backgrounds, and That is the reason we need expertise of all the three major platforms when you want to become a good DevOps engineer. So this diagram again nicely explains the processes, or the end result of a good DevOps implementation. If you see the dark blue circle on your left hand side, you have this plan, code, build, test, and release steps. And on the green one talks about the release, deploy, operate, and monitor steps. So the blue one, the dev side, is the one which is typically followed by the developers, and the green one is the one which is typically followed by the operations folks, right? End of the DevOps, or once the DevOps is implemented properly, these two feedback loops become one, and it becomes a big infinite loop of release and feedback for all your code and deployment targets. That is the end result of a nicely implemented DevOps toolchain and DevOps practices in any company or project. So a couple of building blocks of DevOps which we want to discuss is, the first one is the culture, and I cannot emphasize enough on the importance of it, because no matter how great how great your technological tools are, how great your efficiencies are, unless you have a good and a conducive culture for implementing DevOps, unless the developers and the operations folks who are working with you in your company, unless they change the mindset, how they what is the approach they take to solve a problem, you cannot achieve proper DevOps. Next in the list we have infrastructure automation, which talks primarily about automation of infrastructure, which solves the problem of having to be physically present in a data center to provision hardware and make network changes. So the major benefit is that you no longer have to build a server from scratch. You buy power and connectivity in a data center, manually plug in a machine into the network. All these things have been taken away. All these things have been abstracted away as an end user from you. So what happens is you get the benefit of cloud services, which gives you the elasticity and the scalability features, and you can provision automatically without having to pay for hardware upfront. And DevOps is predicted on the idea that all elements of technology infrastructure can be controlled through code, right? So we think of it as anything as code, we call it, right? So for example, we have infrastructure as code, we have security as code, we have compliance as code, right? With the rise of the cloud, it all can be done in real time via a web service. So typically we are talking about web services, APIs, microservices, all these things which have been predominant in the developers side for quite some time now. We are trying to implement all those things on the operations side to make things more efficient and faster. And treating infrastructure as code helps make operations a seamless fabric. Some of the tools which you use to achieve this, some of the industry leaders are Chef, Puppet, Ansible, Salt, PowerShell DSC, and a lot of other tools are there. So configuration management is like it's like a two faces of the same coin when we talk about infrastructure automation and configuration management. So with the help of configuration management, you basically achieve the infrastructure automation, what we have discussed in the previous slide, and that is the reason the tools which I have listed here is again same which we spoke about in the previous slide. So Chef, Puppet, Ansible are the tools which are the industry leaders at the moment, and they are the tools which you choose in order to make your infrastructure transform into code. And some of the benefits of configuration management is that it solves the problem of having to manually install and configure packages once the hardware is in place. Everything is automated here, right? And the benefit of using configuration automation solutions is that the servers are deployed exactly the same way every single time. And one of the other major benefit is that if you need to make a change across 10,000 servers, you need to make a change only in one place, and then you can replicate the same thing all over again into 1,000, 10,000, even a lakh of servers if you need to. Another important component of DevOps toolchain is source code management, or also known as a version control system. It is a category of software tools that help a software team manage changes to source code over time. Now, this is one of the tools which has been used by the developers for quite some time. I mean, I cannot think of a single project, a single software project where we haven't used a version control system. So tools like SVN and Accuriv and Git, TFS, Mercurial, these are the tools which have been used by the developers for quite some time. But now all these tools are being used in the operations side as well because of DevOps. And some of the benefits of using a version control tool is, first of all, it gives you the version tracking capability. So basically, it acts like a time machine to your code, where you can go back and forth into whenever you want to make any changes to your code base, and when you want to see things, how it has evolved over time. That the coordination within the team, if you have a developer, you have a professionals of a set of 10 people or 20 people, all they can coordinate in a very nice and easy manner if you have a version control system. And lastly, we have something called due diligence. So what happens is, if let's say you need to investigate what has happened in the past which actually broke the code, and or if you want to see what exactly happened over time to your infrastructure or something like that, then you can definitely use these tools. All this information is just a couple of commands away from you because of these VCS or source code management tools. So of course, if a mistake is made, developers can turn back the clock and compare earlier versions of the code to help fix the mistake while minimizing disruption to all the other team members. Continuous integration is perhaps the most important aspect of DevOps, because we talk all the time about CI/CD pipeline. I think this is one of the buzzwords which you must have heard by now, continuous integration and continuous delivery. So this is where the main DevOps principle lies, that it's a development practice that requires developers to integrate code into a shared repository several times a day. Once that is done, each check-in is then verified by an automated build, allowing teams to detect problems early. And by integrating regularly, you can detect errors quickly and locate them more easily. This has been nicely summarized by the chief evangelist of ThoughtWorks Go, Martin Fowler. He says that continuous integration does not get rid of bugs, but it makes them dramatically easier to find and remove. Continuous delivery is the natural extension of continuous integration. It takes over from where continuous integration left off, and it helps large organizations become lean, agile, and innovative as startups. So through reliable, low-risk releases, continuous delivery makes it possible to continuously adapt software in line with user feedback, shifts in the market, and changes to business strategy. So as I told you, it's a natural extension of continuous integration, an approach in which team ensure that every change to the system is releasable, and that we can release any version at the push of a button. Right. So the main aim of continuous delivery is to make releases boring, so we can deliver frequently and get fast feedback on what users care about. Continuous deployment is the next step of continuous delivery. Each change that passes the automated tests is deployed to production automatically. So the major difference between continuous delivery and continuous deployment is that one small element wherein you have to push the button to deploy the code on the production machines if you're using continuous delivery pipeline, whereas if you're using continuous deployment, it is a seamless trigger of events, and eventually, your code is deployed as one single step right from the time when somebody has committed the code, and all the way it goes to the production environment in one single seamless pipeline. And continuous deployment should be the goal of most companies that are not constrained by regulatory or other requirements. So what we mean is that if you don't have to let's say follow a release cycle, or if you're not really bothered about the maintenance window, you can definitely opt for continuous deployment against continuous delivery. Delivery is most apt for the projects or the organizations where you have to follow a release cycle, or where you have to follow a maintenance window, right? You must have heard of the companies which are releasing their code bases onto production machines multiple times on a single day during business hours. So all that is possible because of continuous deployment. And one important thing to remember, that continuous delivery is not something which is an IT limitation. It is more like a point which is to be decided whether continuous deployment is right for your company based on business needs. That is what drives the decision whether you want to implement continuous delivery or continuous deployment in your company. Once again, deployment automation is one such practice which helps you create a seamless CI/CD pipeline. In this umbrella, we are basically talking about the tools which help you automate the deployment process. Tools like Urban Code Deploy, Octopus Deploy, Excel Deploy. These are the tools which you have been used primarily. So what you do is you basically integrate these tools in your delivery pipeline to make it a seamless operation. And the major advantage which you get with the help of deployment automations is that you have an ability to deploy, upgrade, and roll back complex applications and configuration at the click of a button. Right, rollback is perhaps one of the most important advantages you get once you have a deployment automation tool in place. Because if you don't have that, rollbacks are a real pain, right? And once you have this, you don't have to write scripts anymore or workflows for each application. You have a very nice, seamless, automated pipeline for your deployment needs. Apart from the traditional DevOps tool chains like continuous integration and continuous delivery, configuration management, you have a couple of tools which are, or the processes which are not exactly mainstream, but however they're still very important to have a seamless pipeline and a seamless integration of all the DevOps processes together. So one of them is log management, of course. Today's world, we are talking about thousands and thousands of servers, right? So it's not possible to, if there's a need to analyze your log, it's not possible to log into each and every server and do the log analysis. So rather, we are talking about a centralized log management solutions, tools like Splunk, Logstash, QRadar, Logarithm, which help you aggregate, store, and analyze all your logs in one place. Then we have tools like AppDynamics, New Relics, which help you do the performance management, which is about ensuring your network and applications are performing as expected and providing intelligence when you encounter any sort of problems while running workloads on your production house. And finally, we have a set of monitoring tools, and some of the popular ones are Nagios, Sensu, Zabbix. There are a lot of other tools which are there when it comes to monitoring. You have Tivoli Suite from IBM, you have Sitescope from HP. So there are endless list of tools. Basically, these are tools which help you in monitoring and alerting as a crucial piece, which is to manage operations and making sure that people are notified when there is an infrastructure and a related service which is going down, right? So when we talk about this, we are basically talking about any kind of server, any service, any web page, even a small HPA card or a LAN or a any NIC card, any small piece of component which goes down, you should be alerted for that, so that you don't have a single point of failure in your infrastructure solutions. So with that, we come to end of this video, and we have spoken a lot about DevOps, and we will continue our discussion about DevOps and its methodologies and processes in the next video. So thank you for watching, and see you in the next video.